Hello everyone, welcome to Explore Hub. Today we will find the area shaded by the region that lies inside the first curve and outside the second curve. So the first curve we've been given is r is equals to 2 sine theta, and the second curve is r is equals to 1. So we have to find the shaded region between these two curves. So let's draw these two curves out. If this is 1 and this is -1, then r is equals to 1 would be a circle, basically, time with a radius 1, something like this. And then 2 sine theta would be another circular shape, but this time function will start at 0. So it would be something like, now that we have that, we need to find the area shaded by the region that lies inside the first and outside the second curve. So that means we need to find inside the first and outside the second one would be this area. We need to find out this. So we can find out these two points of intersection by equating these two equations, making r equals to r. We'll get 2 sine theta is equals to 1. Take 2 over here, that becomes sine theta equals to 1 over 2, which we know in the first and second quadrant theta would be pi over 6 and 5 pi over 6. So now that we have this information, we can continue with our question. So whenever we're given two curves and we need to find the region between them, the formula for that is area is equals to, and the first function squared theta minus the second function. This is for polar coordinates. This is the formula that we will be using. So now we know that our region is bounded by a and b, which is pi by 6 and 5 pi over 6. So we can substitute our values in. This would give us 5 pi over 6 pi by 6. This is 1/2. The first function is 2 sine theta whole squared minus the second function r is equals to 1, so that's just 1 squared. This would become area is equals to 5 pi over 6 pi over 6 1/2 4 sine squared theta minus 1 theta. We can just take 1/2 outside, take this and plug this outside, and now this would be our equation. So we can continue on solving this. We can remember the identity that sine squared theta is equals to half 1 minus cos 2 theta. We can plug that identity in. Just remember your identities. So we will get 1 over 2 5 pi over 6 pi over 6 times 4 times 1 over 2 1 minus cos 2 theta minus 1 d theta, and then we can solve. This is 1, this becomes 2, cancels out. Now we can write down 1 over 2 equals to 5 pi over 6 pi over 6 1 minus 2 cos theta 2 theta. When you further simplify this, then this can be further simplified to get 1/2 theta minus 2 sine theta. When we integrate this, 5 pi over 6 pi over 6, which is equal to, now we can plug in, after integrating this, we can plug in these bounds, which would give us half 5 pi over 6 minus sine 5 pi over 3 minus pi over 6 minus sine pi over 3, which, so the equations are very long, so this is taking a long time, but just bear with me. 2 pi over 3 minus under root 3 over 2. And this is basically equals to 1/2 2 pi over 3 plus under root 3 over 2 plus under root 3 over 2, which when we further simplify gives us 2 pi plus 3 under root 3 over 6. And we can just plug this in a calculator and we will get is equal to 1.913. So, and this is our final answer. This is the area bounded by the two curves. Thank you for joining us. I hope to see you in the next lesson.